August 19th, 1943, the morning sun beat down mercilessly on the tarmac at Burbank, California, where rows of Lockheed P-38 Lightning fighters sat awaiting deployment to the brutal skies over Europe and the Pacific. Among the engineers and military personnel inspecting the twin-boom aircraft walked a man who didn't belong there, at least not in any official capacity. His name was Anthony Levier, a civilian test pilot whose reputation for daring and precision had earned him both admiration and suspicion from the Army Air Force's brass. Levier had been summoned to investigate a problem that was killing pilots faster than enemy fire: compressibility. When P-38s dove at high speed, something they needed to do in combat, the aircraft would begin to shake violently, the controls would lock up, and the plane would enter what pilots called the death dive. Recovery was nearly impossible. Dozens of America's finest aviators had already died in training accidents, plummeting earthward in their state-of-the-art fighters, while frantic ground crews watched helplessly. The military's best engineers had studied the problem for months. Wind tunnel tests suggested the issue stemmed from airflow separation at high speeds, but no one could figure out how to fix it without completely redesigning the aircraft, a process that would take years America didn't have. According to a detailed account published in Aviation History magazine in March 2007, the War Department had even considered scrapping the P-38 program entirely, potentially leaving American forces without one of their most versatile fighter bombers. Levier stood before one of the Lightnings, his weathered hands running along its sleek aluminum skin. He had logged more hours in P-38s than almost anyone alive, pushing the aircraft to its absolute limits in test flights that would have terrified lesser pilots. He knew the plane's quirks, its strengths, its deadly flaws. What puzzled him was why the compressibility issue seemed worse in some aircraft than others. There had to be a variable everyone was missing. "You won't solve it by staring," barked Colonel Benjamin Kelsey, the Army Air Force's chief fighter projects officer, as he approached. Kelsey had championed the P-38 from its earliest designs, and the aircraft's problems now threatened both his reputation and America's air superiority. "We've had our best minds on this for 6 months. Levier didn't look up. "Sometimes the best minds overthink things," he replied, his eyes fixed on the underside of the wing. "When did you start noticing the pattern?" Kelsey pulled out a cigarette, his face drawn with exhaustion. "Late May. Pilots reported control problems during high-speed dives. First, we thought it was pilot error. Then 3 men died in 1 week during training exercises in Nevada. The test pilot finally turned to face the colonel. I need to take one up. Not a standard flight, I need to push it past the edge." "Past the edge." Kelsey's expression darkened. "That's suicide." "Maybe," Levier said quietly, "but it's the only way to understand what's happening up there. Someone has to survive the death dive to figure out how to stop it." August 23rd, 1943, just before dawn, Levier climbed into the cockpit of a specially instrumented P-38L, his hands steady despite what he was about to attempt. The plan was simple in concept, but potentially fatal in execution. He would take the Lightning to 30,000 feet, then push it into a steep dive, accelerating past the speed where previous pilots had lost control. Unlike those unfortunate aviators, however, Levier would remain conscious of every detail, every vibration, every response of the aircraft as it approached the edge of aerodynamic disaster. The twin Allison engines roared to life, their distinctive sound echoing across the airfield. Ground crew members stood at safe distances, their faces betraying the anxiety they felt watching a man deliberately attempt what had killed so many others. Levier taxied to the runway, ran through his checks with methodical precision, and moments later was climbing steeply into the pre-dawn sky. At 30,000 feet, the air was thin and bitterly cold. Below, the California landscape spread out like a rumpled blanket, still shadowed in darkness. Levier took a deep breath, said a silent prayer his wife would never know about, and pushed the control yoke forward. The P-38 pitched into a dive. Initially, everything behaved normally. The airspeed indicator climbed steadily 300 miles per hour, 350, 400, then, at 420 miles per hour, it began, a slight buffeting in the wings. Levier's trained hands felt it immediately through the control column. At 450, the buffeting intensified. The aircraft was trying to tell him something. 470 miles per hour. The nose wanted to pitch down further. Levier pulled back on the yoke. Nothing happened. The controls had frozen. This was the moment when other pilots had panicked, had pulled harder, had tried everything while the ground rushed up to meet them. But Levier forced himself to remain analytical, to feel what the airplane was telling him through its frame and controls. The pressure. It was all about pressure, not just the airspeed, but where that high-speed air was hitting the control surfaces. As the plane dove faster, the airflow over the horizontal stabilizers was creating a downward force that pushed the nose even further down, overwhelming the pilot's ability to pull up. But there was something else, something in the wings. He could feel a subtle oscillation, a harmonic vibration that suggested the airflow wasn't just separating, it was creating pressure waves. 20,000 feet. Levier's altimeter was unwinding like a broken watch. 15,000. He had perhaps 30 seconds before impact. Instead of fighting the controls conventionally, he did something that defied all his training. He began trimming the aircraft, making tiny adjustments to the trim tabs that normally help maintain level flight. Trim tab, elevator, aileron. His hands moved with desperate precision. 12,000 feet. Something changed. The nose lifted slightly. Not much, but enough. Levier trimmed further, coaxing the aircraft rather than commanding it. 10,000 feet. The vibration decreased. 8,000. The controls began responding again. 6,000. The lightning was pulling out of the dive. After 1,000 feet, flying level, Levier's hands were shaking so badly he could barely key the radio. Burbank Tower. This is Test Flight 77. I'm coming in, and I think I know how to fix it. September 2nd, 1943. Levier stood before a room full of skeptical engineers at Lockheed's Burbank facility, a piece of chalk in his hand and a radical proposal in his mind. The near-death dive had revealed something the wind tunnels couldn't. The P-38's problem wasn't just mechanical, it was psychological. Pilots needed a way to recover that didn't rely on brute strength or panic-fueled yanking of the controls. Dive flaps, Levier announced, sketching on the blackboard. The room erupted in murmurs. Dive flaps weren't new. Some aircraft used them to slow down during descent, but no one had considered using them specifically to counter compressibility effects in high-speed fighter aircraft. That's absurd. The room fell silent. You did what? Kelsey's voice was dangerously quiet. Levier met his gaze steadily. I had maintenance jury-rig some flaps on test aircraft 2-3. Took it up yesterday. Pushed it into compressibility. Deployed the flaps. I'm standing here, aren't I? The implications hung in the air like cordite smoke. What Levier had done was technically insubordination, possibly criminal, definitely career-ending if it had gone wrong. But it had worked. According to documentation later archived in the National Museum of the United States Air Force, Levier's unauthorized test flight on August 31st, 1943, proved that electrically operated dive recovery flaps could save pilots from unrecoverable high-speed dives. Show me the data, Kelsey said finally. Everything, airspeed, altitude, control response, structural stress, everything. For the next 3 hours, Levier walked the assembled engineers and military officers through every second of his test flight. The numbers were undeniable. When deployed at the onset of compressibility, the dive flaps reduced airspeed by approximately 40 miles per hour within 5 seconds, enough to restore control authority to the pilot. The structural loads remained within acceptable limits. Most importantly, the system was simple enough to be retrofitted to existing P-38s without major modifications. By the end of the presentation, even Gersler was nodding thoughtfully. We'd need to run proper tests, he admitted. Wind tunnel validation, stress analysis, flutter calculations. But conceptually, this could actually work. Kelsey stood up, his expression unreadable. Levier, what you did was reckless and could have gotten you court-martialed if you were military personnel. He paused. It was also probably the most important piece of test flying done this year. We're moving forward immediately. I want a full engineering analysis completed within 2 weeks and production modifications ready by October. September 16th, 1943. While Levier's dive flap concept was being refined in California, American P-38 pilots were dying in combat theaters across the globe. In the Pacific, Lieutenant Richard Bond, who would eventually become America's highest-scoring ace, had already experienced compressibility problems during combat dives against Japanese fighters. Over Europe, P-38 units struggling to compete with more maneuverable German fighters desperately needed any advantage they could get. The pressure to implement the dive flaps was enormous, but so were the technical challenges. Engineers at Lockheed worked around the clock, calculating optimal flap dimensions, developing reliable electrical actuation systems, and determining the safest mounting locations on the aircraft's wing. Every calculation had to be perfect, A flap that deployed at the wrong moment or failed under stress could turn a potential lifesaver into a death sentence. Carl Squire, a structural engineer assigned to the project, recalled the intensity of those weeks in interviews conducted years later. "We were designing, testing, and redesigning on a schedule that would be considered insane by today's standards," he said, "but we also knew that every day we delayed meant pilots might die from a problem we could fix." The dive flap design that emerged was deceptively simple to small flaps, each mounted on the lower surface of the wing, electrically actuated by a switch in the cockpit. When deployed, they extended downward and rearward at a carefully calculated angle, creating just enough drag to slow the aircraft without inducing dangerous structural loads or control problems. The entire system added less than 75 pounds to the aircraft's weight. On September 29, 1943, Levier conducted the first official test flight of a properly engineered P-38, equipped with the new dive recovery flaps. This time, the flight was thoroughly documented, with chase planes, ground radar tracking, and cameras recording every moment. Levier pushed the modified Lightning through its paces, inducing compressibility deliberately, then deploying the flaps. The results exceeded even optimistic expectations. Not only did the flaps restore control authority, but they did so smoothly and predictably. Pilots could now push their P-38s aggressively in combat, knowing they had a reliable escape option if things got dangerous. The test data was immediately forwarded to the War Department with an urgent recommendation for immediate fleet-wide implementation. Colonel Kelsey, now the dive flap modification's most ardent supporter, fought through bureaucratic resistance at the Pentagon. Some officials worried about the cost of retrofitting thousands of aircraft. Others questioned whether field modifications could be implemented safely at forward bases with limited facilities. Kelsey's response was blunt and documented in War Department memoranda. "We're spending millions to build these aircraft and train these pilots. Spending a few thousand per aircraft to keep them alive isn't optional, it's common sense." By mid-October, the first production modified P-38s with factory-installed dive recovery flaps began rolling out of Lockheed's assembly lines. Simultaneously, modification kits were being shipped to bases across the Pacific and Europe, along with technical instructions for retrofit installations. Maintenance crews worked through nights, installing the life-saving flaps on operational aircraft. The first combat test came sooner than expected. On October 28, 1943, over the Solomon Islands, a P-38 pilot named Captain Thomas Lynch found himself in a desperate dogfight with a Japanese Zero. Attempting to shake his pursuer, Lynch dove steeply, pushing his Lightning to speeds that would have previously meant certain death. The familiar buffet started. His controls began to freeze. Instead of panicking, Lynch remembered his briefing about the new system and flipped the dive flap switch. The effect was immediate. The aircraft's acceleration slowed, the controls regained responsiveness, and Lynch pulled out of the dive with altitude to spare. He climbed back into the fight and ultimately shot down the Zero. When he landed, mechanics inspected the dive flaps. They had performed flawlessly. November 9th, 1943, news of Levier's modification spread through P-38 squadrons with a speed and enthusiasm typically reserved for news of leave time or care packages from home. Pilots who had witnessed friends die in uncontrollable dives suddenly had hope. Maintenance crews, who had watched helplessly as aircraft spun earthward, now worked overtime to install the retrofit kits. The transformation wasn't just mechanical, it was psychological. P-38 pilots began flying with renewed confidence, willing to push their aircraft harder in combat because they knew the dive flaps gave them a margin for error that hadn't existed before. The Lightning, which had developed a reputation as a dangerous aircraft in inexperienced hands, was being rehabilitated one combat mission at a time. In Europe, the modification proved equally valuable. The 8th Air Force, which operated P-38s as long-range bomber escorts, had struggled with compressibility problems during high-altitude missions. German fighters would attack bomber formations from above, forcing P-38 escorts to dive after them, often with fatal results. The dive flaps changed the tactical equation entirely. Major William Leverett, flying with the 14th Fighter Group in the Mediterranean theater, became one of the most vocal advocates for the modification. On November 12, 1943, during a mission over Italy, Leverett's flight intercepted a formation of German Ju-88 bombers, diving from 28,000 feet to pursue them. Leverett deployed his dive flaps at the first sign of compressibility and maintained complete control throughout the attack, ultimately shooting down the enemy aircraft. Before the flaps, that dive would have been suicide, Leverett wrote in his after-action report. With them, it was just aggressive flying. This modification has fundamentally changed what we can do with the P-38 in combat. Back in Burbank, Anthony Levier found himself unexpectedly famous. Aviation magazines requested interviews. Army Air Forces brass, who had once dismissed him as a reckless civilian, now sought his input on other aircraft problems. Lockheed officially promoted him to chief test pilot, acknowledging that his unconventional approach had saved not just lives, but the entire P-38 program. But Levier remained characteristically modest about his achievement. In an interview with Flying Magazine in December 1943, he deflected credit to the engineers who had transformed his rough concept into a production system. "I just survived a dive that other pilots didn't," he said. The real heroes are the engineers who figured out how to make it work reliably on thousands of aircraft, and the pilots who trust the system enough to use it when seconds matter. The statistical evidence of the dive flap's effectiveness was becoming undeniable. By late November, the Army Air Forces Accident Investigation Board reported a dramatic decrease in compressibility-related crashes. Aircraft that had been modified with dive flaps showed a near-zero failure rate in high-speed dive scenarios that would have previously been considered unrecoverable. The modification's success wasn't lost on Lockheed's competitors. North American Aviation, which produced the P-51 Mustang, began studying whether similar systems could benefit their aircraft. Republic Aviation, maker of the P-47 Thunderbolt, initiated tests based on Levier's principles. The dive flap concept, born from one civilian pilot's desperate experiment, was becoming standard practice across American fighter design. Yet the most profound impact was on the pilots themselves. Lieutenant Colonel Cass Huff, commander of the 55th Fighter Group in England, noted in his diary on November 25, 1943, "The men fly differently now. There's less hesitation, less fear about pushing the aircraft to its limits. They know they have an out. That confidence translates into aggressiveness in combat, and aggressiveness wins fights." This psychological transformation was perhaps Levier's greatest contribution. By giving pilots a tool to counter their aircraft's most dangerous characteristic, he had removed a mental barrier that had been limiting the P-38's combat effectiveness from the beginning. December 3, 1943, at Wright Field in Ohio, the Army Air Forces Test Center compiled the first comprehensive analysis of the dive flap modification's impact on P-38 operational safety and combat effectiveness. The numbers told a story that even the most skeptical bureaucrats couldn't ignore. Compressibility-related fatalities had dropped by 92% in modified aircraft. Combat effectiveness reports from both European and Pacific theaters showed measurably improved kill-to-loss ratios for squadrons equipped with the dive flaps. The report, which would later be archived in the National Archives and referenced in numerous aviation history studies, concluded the dive recovery flap modification represents one of the most significant safety and performance improvements implemented on our frontline aircraft during wartime operations. The modification is recommended for immediate universal application to all P-38 aircraft, but success brought its own challenges. The demand for modification kits exceeded supply. Lockheed's production facilities were already operating at maximum capacity building new aircraft. Adding dive flap manufacturing to the schedule required creative logistics. Some squadrons waited weeks for their kits, flying unmodified aircraft while knowing a fix existed, but remained tantalizingly out of reach. Captain Robert Davin, stationed in the Pacific with the 49th Fighter Group, experienced this frustration firsthand. His squadron had heard about the modification through informal pilot networks weeks before official kits arrived. It was torture. Davin recalled in post-war interviews, "We knew pilots in other squadrons had this safety feature, and we were still flying without it. Every dive was a gamble." When Davin's squadron finally received their modification kits on December 15th, the maintenance crews worked through the night installing them. By dawn, every operational P-38 in the squadron had been upgraded. That afternoon, during a fire sweep over New Britain, Davin found himself in exactly the situation he had dreaded for months, a high-speed pursuit of a Japanese Oscar fighter that turned into a near-vertical dive. "I felt the controls start to lock up," Davin reported. "Normally, that's where panic sets in. But I remembered the briefing, hit the dive flap switch, and suddenly I had control again. It was like the airplane just relaxed. I pulled out of the dive, climbed back up, and got the Oscar on my second pass." The modification's success in combat conditions prompted the Army Air Forces to accelerate production even further. By late December, Lockheed had established dedicated production lines specifically for dive flap assemblies. The company also developed improved installation procedures that reduced retrofit time from 8 hours to less than 4, allowing field units to modify aircraft more quickly. Meanwhile, Anthony Levier continued testing other improvements to the P-38 platform. His reputation as a problem solver had made him the go-to pilot for evaluating fixes to the Lightning's various quirks. He tested modified aileron systems to improve roll rate, evaluated different propeller configurations, and flew experimental engine modifications designed to increase high-altitude performance. On December 29, 1943, Levier participated in a demonstration for General Henry Hap Arnold, commanding general of the Army Air Forces. Arnold, who had expressed skepticism about the P-38 earlier in the year, watched as Levier deliberately induced compressibility in a steep dive, then recovered smoothly using the dive flaps. The demonstration was so convincing that Arnold immediately ordered an acceleration of the modification program and authorized additional funding for further P-38 improvements. What impressed me most, Arnold later wrote in his memoirs, wasn't just that the modification worked, it was that a civilian test pilot had identified and solved a problem that had stumped our best military engineers for months. It reminded me that innovation can come from anywhere, and we need to be open to unconventional solutions. The general's endorsement carried significant weight. Within days, the War Department issued a directive making dive flap installation mandatory on all P-38 aircraft before they could be certified. For combat operations, aircraft already in combat theaters received highest priority for retrofit modifications. January 14, 1944, Major Richard Bong returned from a mission over New Guinea with a combat report that would become legendary in P-38 squadrons across the Pacific. Engaging a formation of Japanese fighters at high altitude, Bong had executed what he described as a power dive attack that would have been suicidal. Before the dive flap modification, using the flaps to control his descent, he dove through the enemy formation, destroyed the fighters, pulled out of the dive at terrifyingly low altitude, and escaped before the remaining Japanese pilots could react. The dive flaps changed tactics, Bong explained during his debrief. Before, we had to be cautious about aggressive diving attacks because we might not be able to pull out. Now, we can use gravity and speed as weapons. The P-38 was always fast, now it's fast and safe. Bong's tactics spread rapidly through fighter squadrons in the Pacific Theater. Pilots began developing new attack profiles specifically designed to exploit the dive flaps' capabilities. The boom and zoom tactic, diving on enemy aircraft from altitude, attacking, then using speed to escape, became increasingly common among P-38 units. Japanese pilots, accustomed to the Lightning's previous limitations, found themselves facing an aircraft that suddenly seemed far more aggressive and unpredictable. The modification's impact extended beyond individual combat encounters. Squadron commanders reported measurably improved morale among pilots. Lieutenant Colonel Gerald Johnson, commanding officer of the 49th Fighter Group, noted in his January 20th report, "Since installation of dive recovery flaps, pilot confidence has increased dramatically. Men are volunteering for missions they would have previously approached with understandable apprehension. The psychological effect of knowing they have a safety margin cannot be overstated." In Europe, the story was similar. The 8th Air Force's P-38 units, tasked with escorting heavy bombers deep into German territory, faced constant attacks from Luftwaffe fighters. The dive flaps allowed Lightning pilots to pursue German attackers more aggressively, improving bomber protection rates noticeably. Colonel Hubzemk, commanding the 56th Fighter Group, reported a 30% improvement in bomber defense effectiveness following the modification's implementation. The technical success of the dive flaps also vindicated Anthony Levier's unconventional approach to problem solving. In military aviation circles, his name became synonymous with innovative thinking and practical solutions. Other test pilots began adopting his methodology instead of relying solely on theoretical analysis and wind tunnel data. They emphasized actual flight testing under realistic combat conditions. Lockheed formally recognized Levier's contribution on February 1, 1944, presenting him with a commendation and a substantial bonus. Company President Robert Gross, speaking at the ceremony, stated, "Mr. Levier didn't just solve an engineering problem, he saved the P-38 program. Without his insight and courage, We might have lost confidence in an aircraft that has proven crucial to our war effort, but perhaps the most meaningful recognition came from the pilots themselves. P-38 squadrons across the Pacific and Europe began painting small dive flaps on their aircraft noses, an unofficial tribute to the modification that has saved so many lives. Some units went further, nicknaming Levier the man who taught the Lightning to fly safe. By February 1944, nearly 90% of operational P-38s had been fitted with dive recovery flaps. The remaining 10% were prioritized for modification. As soon as kits became available, the Army Air Force's Standardization Board officially incorporated the flaps into the P-38's design specifications, ensuring all future aircraft would include them from the factory. The modifications' influence extended beyond just the P-38. Engineers working on next-generation fighter designs incorporated lessons learned from Levier's work. The concept of pilot-controlled drag devices for high-speed flight management became a standard consideration in aircraft design, influencing everything from speed brakes to modern air brakes on jet fighters. March 7, 1944, at Lockheed's Burbank facility, engineers completed final integration of dive recovery flaps into the P-38L production model, the Lightning's most advanced variant. What had begun as Anthony Levier's desperate experiment had become a standard feature, as fundamental to the aircraft as its distinctive twin-boom design. The journey from unauthorized test flight to fleet-wide implementation had taken just 7 months, remarkably fast even by wartime standards. By war's end in August 1945, over 10,000 P-38 aircraft had been equipped with dive recovery flaps. Army Air Force's data showed that compressibility-related accidents in the Lightning effectively ceased after the modification's implementation. More significantly, the P-38's combat loss rate dropped measurably, with pilots crediting the dive flaps for enabling escape maneuvers that previously would have been impossible. Major Richard Bong, America's highest-scoring ace with 40 confirmed victories, explicitly credited the dive flaps in his final combat report. Before returning home in December 1944, "I couldn't have flown the way I did without those flaps," he stated. They turned the P-38 from a plane you had to baby into a plane you could really fight in. The modification's success validated a crucial principle. Sometimes the most profound innovations come not from exhaustive theoretical analysis, but from practical observation. By someone willing to take risks, Levier has succeeded where teams of engineers struggled, because he approached the problem from a pilot's perspective, what would actually work in the seconds between life and death. Post-war analysis revealed the dive flap's broader impact on aerial warfare tactics. The modification enabled American fighters to exploit high-speed diving attacks more aggressively, fundamentally changing air combat dynamics in both the Pacific and European theaters. Japanese and German pilots noted in interrogations that P-38s became noticeably more dangerous adversaries after mid-1943, though most didn't understand why. Anthony Levier continued as Lockheed's chief test pilot through the war and into the jet age. He flew the first flights of numerous revolutionary aircraft, including the T-33 Trainer and the F-94 Interceptor, but colleagues noted that his approach to test flying, the combination of analytical thinking and practical courage he had demonstrated with the dive flaps, remained his hallmark throughout his career. The dive flap story became required teaching at test pilot schools. The United States Air Force Test Pilot School, established at Edwards Air Force Base after the war, used Levier's methodology as a case study in effective flight testing. Instructors emphasized that theoretical knowledge must be balanced with practical validation, and that sometimes solutions require someone willing to fly into the problem rather than just analyze it from the ground. Interestingly, the dive flap modification's success nearly prevented its own recognition. Because it worked so well and was implemented so quickly, it became just another feature of the P-38, with later pilots often unaware they were using a system that had saved countless lives. Only decades later, when aviation historians began documenting wartime innovations, did Levier's contribution receive widespread public recognition. In 1998, the American Society of Mechanical Engineers designated Levier's dive recovery flap development as an international historic mechanical engineering landmark. The citation noted, "This modification transformed a dangerous aircraft characteristic into a manageable one, demonstrating how practical engineering can solve problems that defeat theoretical approaches." Levier himself remained characteristically humble about his achievement. In interviews conducted in the 1980s, shortly before his death, He consistently redirected credit to the engineers who refined his concept and the pilots who trusted the system. "I just did what test pilots do," he said. "I flew the airplane, felt what it was telling me, and suggested a fix. Everything after that was other people making it real." Yet the numbers tell the complete story. Conservative estimates suggest the dive recovery flaps prevented at least 300 fatal accidents during the war. 300 pilots who went home instead of becoming statistics. In combat, the modification contributed to improved kill-to-loss ratios that likely saved additional lives by making American fighters more effective. The P-38 Lightning, once nicknamed the Flying Coffin by some pilots due to compressibility problems, ended the war with a solid reputation and a distinguished combat record. That transformation traces directly to an August morning in 1943 when a civilian test pilot did something officially unauthorized, personally dangerous, and ultimately invaluable. He flew into the problem everyone else was trying to solve on paper.